Now dear children, we go to the last numerical problem, and this is problem number 3 based on capillarity. And with this numerical problem, your chapter surface tension get completed. Okay, problem number 3 says that two capillary tubes of diameters 5 millimeter, 5.0 millimeter means 5 millimeter, and 4.0 millimeters are held vertically inside water one by one. Means there are two capillary tube having different diameters, and that we are inserting what vertically inside water, okay, one by one, means not together. Okay, the question says that how much high will the water rise in each tube. So we have to find the height of water which rise in each tube. Okay, the value of G means associated gravity is given 10 meter per second square. Surface tension of water is given 7.0 into minus 2 Newton per meter. Okay, now in this question, in this particular question, the value of associated gravity is given, that is 10 meter per second square, and the water as a liquid whose surface tension is also given, that is T equals to 7.0 into minus 2 Newton per meter. Okay, but the water as a liquid has a density also. So density of water is not mentioned out here. So we consider the density of water is rho. So let rho be the density of water. But the tube which we are inserting vertically inside the water have different diameter. So the first tube, capillary tube, whose diameter is given 5 millimeters. So the diameter of first capillary tube is 5 millimeter. So I convert millimeter into meter. So 5 into 10 minus 3 meter. So if this is the diameter of first capillary tube, then we calculate the radius of first capillary tube. And you know radius is half the diameter. So R1. So first capillary tube radius I consider as R1 equals to 5 by 2. So this is half of this, means 5 by 2 minus 3 meter. So 5 by 2 means how much? 2.5 into minus 3 meter. So this is the radius of first capillary tube. But there is another capillary tube whose diameter is 4 millimeter. So the diameter of second capillary tube is 4 millimeter. So I convert again millimeter into meter. So 4 into 10 minus 3 meter. So this is the diameter of second capillary tube. Okay. So if this is the diameter of second capillary tube, then the radius we can also calculate. So radius is R2. For second capillary tube, the radius is R2. That equals to 2 into 10 minus 3 meters. So I wrote directly because half of 4 means 2. So the radius is always half of diameter. So R2 equals to 2 into minus 3 meter. Okay. Now to calculate the height occurred by each tube, let me just write down that H1 and H2. Let H1 and what? H2 are the what? Are the height of water. These are the height. These are the height of water. These are the heights of water, sorry. Okay, inside what? Inside the capillary tube. Okay, inside the what tube? Capillary tubes. And that tube having different diameters. Okay, but to calculate this height H1 and this H2, okay, let me just write the formula of the height occurred by water or liquid in a capillary tube having radius, and the formula is H equals to 2t cos theta by rho g. So children, look at the formula of the height of liquid, or simply we are taking water out here that rise in the capillary tube. It's mentioned and can be measured by 2t cos theta by rho g. So 2 means T means surface tension, cos theta is the angle of contact divided by radius, density, and the associated to gravity. Okay, associated to what? Gravity. Now out here, when we calculate this height, and when the water, a tube is placed vertically inside the water, okay, we assume that the angle of contact between water glass is almost assumed to be how much? 0 degree. And you know angle of contact between water and glass will be 0 degree for which water? Pure water and clean glass plate. Okay, clean glass. So I write down, we assume. So what is the angle of contact that we can assume in this particular question? That is 0 degree. Okay. Now children, we calculate the height occurred by the water in the first capillary tube. Okay, so for that, for first tube, the first capillary tube, the height is expressed by h1 equals to 2t cos theta by r1 rho g. So I am writing r1 because r1 is the radius of first capillary tube, so that the height of the first capillary tube is h1. So h1 equals to 2t cos theta by r1 rho g. Okay, so from this we can calculate the height acquired by the first capillary tube. Now for this, so 2 into t is how much? The surface tension of water, that is given 7 into 10 to the minus what? 2 cos theta, as we have already assumed it is 0 degree. Okay, means we are taking what? Water, pure water and clean glass plate. For pure water and clean glass plate, so angle of contact is 0 degree. Okay, divided by r1. The value of r1 is how much? 2.5 into 10 minus 3. Rho means density. So density of water is basically 1 into 10 to the power 3. So water is that liquid which has a density maximum, that is 1 into 10 to the power 3 what? Kg per meter cube. Okay, and g, the value of g is as given how much? That is 10. So value of g is given 10. Okay, so let's calculate the value. Now let me multiply 2 7s are how much? 14. Okay, into 10 to the power minus 2 cos 0 degree is 1 whole divided by 2.5 into 10 to the power. Now minus 3 plus 3 is 0, and this 10 1. So this 10 only. So this is 0 into 10, because 10 to the power minus 3 and 10 to the power 3, if you add the same power with opposite sign, means 0. Minus 3 plus 3 means 0. So it is 14 into 10 to the power minus 2 by 2.5 into 10. Okay, now let me just multiply this one. Okay, so let me just multiply this one, and let me just do this way. So 10 to the power minus 10 to the power 10 I'll take in the numerator, so I write on 14 by 2.5 into 10 to the power minus 1. So if I minus 2 is already there, minus 1, if I take 10 to the power 1 in the numerator, minus 1, minus 2 minus 1 is minus 3, and this is meter. Now 14, if I divide by 2.5, okay, we get approximately 5.6 into 10 to the power minus 3 meter. So this is the height acquired by the water in the first capillary tube. But this is 10 to the power minus 3 meter. So I can write this even in what? Millimeter, because 10 to the power minus 3 meter means 1 millimeter, which means h1 is how much? 5.6 millimeter. So what is the height of water rises or acquired by the water in the first capillary tube? 5.6 millimeter. Okay, similarly we calculate for second capillary tube. Similarly for second capillary tube, for second capillary tube I calculate the height, and that height I have already considered as s2, and this height s2 equals to how much? 2t, and formula is same, 2t, same surface tension, because same water means same surface tension. Angle of contact is also theta, cos theta by the radius is r2 rho, same density means same water means same density under same gravity. Okay, equals to 2t cos theta means 0 degree by r2 rho g. Okay, so let's do the calculation for this question also. Okay, 2t, t again same, 7 into 10 to the minus 2 cos 0 degree is 1 by r2. Now what is the radius? The second radius that we have calculated, it is 2 into 10 to the minus what? 3 into density of water is same, 1 into 10 to the power 3. Okay, and the gravity value is 10. Okay, so we can cancel 2. Okay, so it will be how much now? 7, I write down same, 10 to the power minus 2 by the 10 to the power minus 3 plus 3 means 0, and this is 10 1. 10 means only 10 to the power 1. Okay, so 7 into 10 to the power minus 2 into 10 to the power minus 1, because 10 to the power 1 if I take in the numerator is minus 1, and 10 to the power 0 means 1. So it is 7 into 10 to the power minus, okay, minus 3, and the unit is what? Meter. So 10 to the minus 3 meter, again I write on in millimeters, so it is 7 millimeter. 7 what? Millimeter. So H2, the height acquired by the what? Acquired by the water in the second capillary tube is H2 equals to 7 millimeter. How much millimeter? 7 millimeter. So we calculated the height acquired by the water in two different capillary tube. One is 5.6 millimeter. Okay, another is 7 millimeter. Okay, so but in this particular problem, you see the height acquired by water in first capillary tube having more diameter, that is 5 millimeter, is 5.6 millimeter, whereas the height acquired by same water in the second capillary tube having diameter 4 millimeter is 7 millimeter. Means smaller the diameter, more the height that is acquired by the liquid in the capillary tube. So this makes the explanation of problem number 3. So children, we have completed problem 3 also, and with this the chapter of surface tension is also completed. Okay, thank you so much.